Alright guys, welcome to our channel Code with Sunny, and today we will be discussing the medium problem, minimum number of arrows to burst balloons. Okay, and its index is 452. So this problem basically requires the prerequisite knowledge of like sortings, and you need to have the greedy type of knowledge to find out the minimum number of arrows, which is our answer. Okay, so there will be some spherical balloons, you can see, taped onto a flat wall, represents xy plane. So balloon has some x coordinate, like starting x coordinate represented by, like, all the balloons have some starting coordinate and some ending coordinate, and this will be given by this points 2D vector. Okay, and this will be a horizontal diameter that is going to be stretched between x start and x end. And actually we don't know the exact y coordinates of the balloon, and we are also not interested to know that arrows can be shot directly vertically in the positive y direction. That is, we have to choose some x coordinate and we have to shot a arrow to burst all the balloons lying in that, whose x coordinate ranges like whose x coordinate is in the range of x. You can see x must lie between the range of this balloon, then this balloon will be bursted, and there is no limit to the number of arrows that can be shot. A short arrow keeps traveling infinitely, bursting any balloons in its path. That is, if we shot a balloon, like if we shot an arrow at a particular x coordinate x, then it will burst all the balloons whose coordinate is going to satisfy this condition. And if we have been given the array of points, we have to return the minimum number of arrows that must be shot to burst all the balloons. Okay, so if you haven't understood this problem yet, I will explain through the diagrams, so no need to worry about. Let's look over the constraints. You can see there will be at most 10 raised to the power 5 balloons. So we would be thinking for a best O of n or O of n log n solution. And you can see the coordinates is going to range from minus 2 raised to the power 31 to 2 raised to the power 31 minus 1. So we are not going to store the coordinates into some array or vector, so that will be a really a foolish thing. So we will be finding it out in the most efficient way, how we are going to have the minimum number of arrows. So let's understand this problem with the help of diagram. Okay, so suppose I have picked this example from the first sample test case. You can see this is the actual sample. Okay, and I plotted this diagram. Okay, so the very first thing that you need to understand is you have been given all these points. Okay, so let me first change this color. Okay, so you have been given all these points. Okay, and you have to short an arrow, like you have to choose some x coordinate where you are going to short an arrow in that x coordinate vertically in a vertical direction. Suppose you have chosen, let's say, x equal to 5, so it will lie somewhere over here, and if you short an arrow, it will just burst all those balloons whose whose coordinates will satisfy this condition: x less than equal to x end. X end is the end coordinate of the balloon, and x start is the start code. You can see this balloon will be bursted and this balloon will be bursted. Okay, so yeah, you are going to use one arrow to short these two balloons. And what about these two balloons, how this can be bursted? So you will choose another some coordinate, let's say x equal to 9, so it will lie somewhere over here, so you will short an arrow. You can see only this will be bursted. Okay, and still this balloon is not bursted, so you will choose some another x and you will burst this balloon. Okay, so like you can have worst case answer as x, let's say answer, that the maximum answer can be exactly equal to the total number of balloons, total number of balloons. And when this will happen, this will happen when all the segments, you can see if you plot it like that, is not going to overlap. That is, some segment is like this one, Okay, and another segment would be like this one, and another would be like this one, and another would be like this one. You can see none of the segments are overlapping. In that case, you can see you are going to short an arrow between this range, short an arrow between this range, short an arrow between this range, and again this one. Here you will get the 4 because all the 4 segments are not going to overlap. Okay, this is the maximum answer that you can have when the you can see when the arrows, sorry, when the segments are not going to overlap. But what about some segments is going to overlap? In that case, my answer would not come out to be n, where n is the total number of balloons. So how we should find out the minimum number of arrows to short up all the balloons? Okay. So you can see when the two segments are going to overlap like over here. So you will the most optimal way is to short an arrow in the overlapping region. You can see this is the overlapping region, right? So we will be shorting an arrow in this overlapping region to burst out the maximum number of balloons. So it will cost me only one arrow, but it will burst more than one balloons. So this is the optimal one. So suppose that there are more number of segments overlapping in this region like this one. So you can see that if we short an arrow within this range, it will burst 4 balloons. 1, 2, 3, 4, because 4 segments are lying over here. So one arrow is going to short 4 balloons. So this will minimize the number of arrows. Okay, but we are interested to solve for this problem, for this sample one. So let's try to understand. So one of the cases like when I first solved this problem, I thought the best case would be like sort all the points, the coordinates in increasing order of x start. Now also one thing that should be noted, I have plotted the points like over here, but you can see the coordinates are like minus 2 raised to the power 31 to 2 raised to the power 31. So you cannot have an array of such a big size. Okay, so you need to find some another way to solve this problem efficiently. So what I have done is like sort all the points in increasing order of x start. So this was my first approach, but this will give us the wrong answer, and like only 22 or 21 test cases have been passed. Like if you can see my submissions, you can see first was the wrong answer. Okay, but later on I have corrected it because I found the mistake. Okay, so first thought would be like sort the points in increasing order. Like you can see if increasing order of x start, now you can see this is the very much starting position. Now your thought would be like first I need to burst this balloon, because if I am not going to burst this balloon, then how it is going to be bursted, because this is x start and this is the minimum. Okay, so I thought would be like I'm not going to burst this balloon at this position, rather than I would be bursting this balloon at the its x end position, like the minimum x start and its x end position like over here. So I will be bursting the balloon right up to here. Okay, like I'm shorting an arrow at x equal to 6. Okay, so it will burst these two balloons. Okay, now these two balloons have been bursted. Now I will move on to the next x start, which is the next minimum. Okay, now these two have been bursted, so I would come over here. So I would go to the its x end position and I will burst it out, like I burst and I file an arrow right over here, like x equal to 12. You can see these two balloons have been bursted, so our answer comes out to be 2, like using an arrow at this position and using an arrow at this position. Okay, so this is going to be the minimum answer. Yeah, so if I will sort all the points in increasing order of x start, so I will pick some minimum x start and take its x end, and I will use file an arrow at this x end position, and I will move on to the next x start. And if x start is still less than or equal to its x end, I will say yes, this can still be bursted with the help of this x end. Okay, if you're not going to get it, suppose that I'm choosing this x start and I will fixing this x end, like I'm filing an arrow at this position, like for all those next points whose x start is going to be like less than equal to this x end, like somewhere over here. Okay, but this can be easily bursted if we are going to file an arrow at this x end position, that is x equal to 6. Okay, but when this x start is going to be strictly greater than this x end is 6, you can see this x start, this one, this segment, has x start as 7 and the previous x end was 6. So this balloon is not going to be bursted. So my x end will change now, and x end will change to x end equal to 12. I'm now filing an arrow at this position. Okay, this was for sorting all the points in increasing order of x start, but this will give you the wrong answer. Why this will give you the wrong answer? So it will, like, let me move on to the next example, where that would be a much interesting one. Okay, so what will happen is, like, suppose I will sort all the points or the balloons in increasing order of x start. Okay, so what will happen is, like, you can see this is the actual point. So this is the, like, this is the balloon whose x start is minimum. So I will move on to its x end, and I will file an arrow at this position, which is x equal to 10. Okay, so what will happen is, if I will file an arrow at this position, you can see what is the minimum number of arrows required to burst all the balloons. So according to our idea, that it should have bursted all the balloons lying whose x start is going to be less than or equal to this current value 10, and x end is going to be, like, greater than this 10. But you can see there are some of the arrows which are not going to be bursted. You can see this one arrow, like this arrow. This is not going to be bursted because its x end is also less than this position, which is 10. So our idea of sorting all the points in the increasing order of x start is actually a wrong. So we will sort, so what could be the best way to solve this one? So I will sort all the coordinates in the increasing order of x end. Why? Because if some x end is going to be lesser than this one, so this balloon must be bursted. So if this balloon must be bursted, so I will first file an arrow at this position. So what will happen is, like, just look out over here. What is the minimum x end for all those arrows? You can see the minimum x end is coming out to be 7 for all those arrows. So I will file an arrow over here. So you can see this is the minimum x end. So all the balloons whose coordinates is going to be, like, whose range is going to be satisfying this condition of x start less than equal to 7 less than equal to x end will be bursted. So you can see this one is not going to be bursted. Wait a minute. Yeah, this one bursted, this one bursted, this one also, this one also. Okay, now the remaining these two are not going to be bursted. So again I will move on to the next x end minimum, and the balloon is still not bursted. So you will find out next x end minimum is again 12. So I will file an arrow at this position, and you can see all these two balloons are bursted. So my minimum answer comes out to be 2. Okay, so the most optimal way is to sort all the points in the increasing order of x end. Okay, so let's move on to the submission. Yeah, so you can see I've sorted all the points in the increasing order of their ending position. Okay, so you can see this will be the sorting part, and my minimum, like, my initial answer is 1, and I'm bursting the arrow at this position, points of 0 1, like the minimum x end for all the balloons. Okay, so I will iterate for the remaining balloons, and if my current starting coordinate, that is x start, is going to be the strictly greater than the current end, then I need to file an arrow, like I need to file another arrow, and the next arrow that should be filed at some x coordinate will be exactly equal to this one. Okay, so let's understand over here again. So this is the initial x end. Okay, so I will choose this one, and I will just iterate for all those values. You can see this one has x start strictly less than this 7, and again this one has a x start strictly less than 7, and this one also, this one also. But when you come over here, this x start has is greater than, strictly greater than this 7, so you need to file another arrow. So the next arrow that should be filed will be the at this position, that is x end position of this balloon. Okay, so yeah, so you need to increment your answer and assign this value, and each time you are going to have the best possible answer at this position. So finally return the answer. So this will give you all test cases passed. So what will be the time complexity of this approach? Would be, you can see the sorting takes n log n time. O of n log n, yeah, sorting takes n log n time complexity, O of n log n. And what about the space complexity? You can see I am using exactly one variable or two, which should be O of 1. Yeah, so this will pass all the test cases. Yeah, so if you guys have any doubts, do let me know in the comment section of the video, and thank you for watching this video.